Today we are going to discuss about decision trees. So far we have covered two different models. So one of the model was our linear regression, wherein we discussed a point wherein the the data set was something like this. We have a x feature and a y feature, and there was some kind of a linear relationship between x and y. And as against that, when we take logistic regression, we had two classes. Let us say that the green dots are class 1 and the orange dots are class 2, and we had to find out some kind of a relationship which can, I mean, some kind of a hyperplane which can divide these things. And we discussed many things, like, there is a assumption that there is linear relationship and they're linearly separable, and there are no outliers, all those assumptions. And these models are also very sensitive. Like, if you have any outlier, then there is a lot of drift the model takes, and eventually what happens is we observe very high error in the predictions. So in order to control this, we need some sort of a model which is not linear at the end of the day. So that is why we have a requirement of more complicated model like decision trees. Now what happens in a decision tree is it follows some kind of a flowchart model. Say, when you have a data set wherein you can ask some questions, and based on the outcomes, you decide whether to make one decision or not. Say, for example, if I talk about giving loan, I might have some kind of questions like if the person is having any job or not, how long the person is working in that company, what is his salary like, does he have any existing loans. So this kind of a data set is like you can ask many number of questions, and based on the outcomes, you're trying to come to a conclusion whether you have to give loan to the person or you don't want to give loan to the person. It need not be categorical data. It can also be a continuous data. Say, for example, my height is below the average, or let us say my salary is above the salary of the complete region or the complete company. Based on that, even if it is a continuous feature, you can still ask questions. It need not be just yes or no, or just male or female. Okay, so decision trees can be imagined like a flow chart, wherein you start off with one question, you get couple of answers, and for each answer you ask further more questions. Now the task is like which question to ask first. Now, as I said, like, I can ask whether the person's job is private or government, but why should I first ask about the job? Why not about the age, or why not about the property? So in decision trees, what happens is it follows some kind of a rule. Okay, and that rule comes to a gives some kind of a correlation, which is nothing but entropy or Gini index. Okay, and it makes some decision, or you can say it comes to a conclusion saying, if I ask this question, I can converge more fastly as compared to any other column. Okay, if I start with salary as my first question instead of age as my first question, I can come to a conclusion that I can give the loan or not. Okay, if my salary is below 10,000, I cannot give loan of 2 crores. Okay, as simple as that. So first question will be salary. Because your salary is very less, you're classified as class 0, you'll not get the loan. As simple as that. So it all depends upon which question to ask first. So in this case, what we'll be having is we will be having many rows and columns. Okay, now these are the rows, as you already know, and these are the columns, and you will have one target. Again, this is a supervised learning wherein you already know the ground truth. Maybe you are giving a loan or you are not giving a loan. And then based on this features that we have, like this column 1, column 2, column 3, and so on, we will take one column and try to find out, if I divide from this column to come to this conclusion, what is the information gain I'm getting. I think we already discussed about entropy, Gini index, and information gain in the last session. So if you did not cover it, I would highly suggest that you should first look at that particular point, and then it will be very easy for you to understand what decision tree is. But so far we have discussed only few things. Okay, we have some kind of a flow chart. We ask one question, we come to find out that there are different set of possible answers: above average, near the average, or below average. For this we can ask further questions. For this we can ask further questions. We can here also we can ask further questions. We'll continue to keep asking question until we reach to a point where all the records belong to class 0 or all the records belong to class 1. We are asking the questions keeping in mind that we have to divide the dataset to class 0 and class 1. But decision trees can be applied to both classification and regression problems. So you can imagine like you have different set of child nodes here. I'll talk about node and root in a while. But when you come here, I can say my average is somewhere here, or I can say here my average is somewhere, some other place. So if it is a continuous column also, you will have a different mean. The mean of this particular data set will be different from this particular data set. Okay, so understanding the classification is more easy. That is why I'm telling you about decision tree classifier. But nevertheless, you can apply, you can also use, there is something called as decision tree regressor, which can be applied on a continuous feature. So if you understand what is decision tree classifier, I think decision tree regressor should not be a big problem. Okay, so two things. One is to identify if the data set is really good for us to use decision trees or not. If you think that by asking simple questions I'm able to come to a conclusion, then most likely decision tree can be one of your best choice. Okay, and then the second point that you have to remember is decision tree chooses which column to split based on factors of entropy and Gini index. These are nothing but our measures of impurity. You can find out that in the video, wherein all the records belonging to class 0 will have 0 impurity, or all the records belonging to class 1 will have 0 impurity. Okay, when there is a mixture, probably then you will find that there is a impurity which is a non-zero value. Okay, so that is what we discussed in the last session. But anyway, now let us move ahead. So as I was mentioning that we will be asking a lot of questions. So here in this case, what I did was I first identified whether the person is uh, working in a private job or in a government job. If the person is having a government job, whether his salary is greater than 30,000 or not. If the person is working in a private job, whether the salary is greater than 50,000 or not. So you can see that every node I'm asking one of the different questions, and then finally trying to understand whether the person is eligible to be given loan or is not eligible to give loan. This is how the flowchart looks like. Of course, the flowchart usually runs from top to bottom, but in this case, for the simplicity of understanding in decision trees, I have given it in a reverse way. Okay, just like this of how you see the flowchart, our decision tree also looks the same way. Now in decision tree, what happens is we start off from a root node by calculating the measures of impurity and information gain. We have entropy, Gini index, and information gain. We'll be most likely be using at entropy, but some cases we can also use Gini index. We will compare the entropy at the root level, and keeping in mind how many, if I differentiate at the root level, how many records are getting classified as class 0 and how many records are getting classified as class 1. At the end of the day, we have to achieve to this part, class 0 or class 1. Let us say that we have only two classes for now. So everything what we are trying to do is we are trying to come to a point where all the records belong to only one class, either class 0 or class 1. And then we differentiate the entropies of the root level and the child level, and then you can find out what is the information gain. Okay, so once the highest information gain column is identified, from that we will be trying to make the decision tree grow. That is why it is called as decision tree. It looks like a tree, right? It has many branches. This is called as a root node, our first column based on which we differentiate our data. And this first column is called as a root node. Root node is then split into two or more. It need not be two. So in this cases, you see only two child nodes. Actually, here also there is a child node, but because it all belongs to the same data set, we do not show. So you can have any number of child nodes, like one root node can be split into 3 or 4 or 5. Even this is a hyperparameter for the decision tree. And bigger the decision tree, bigger is a problem that we'll discuss at a later point. Okay. But for now, by using this information gain, it is trying to achieve to this conclusion at a faster rate. Just keep that in mind. Okay. This is how what the decision tree looks like. Now we'll move further. So what is the advantage of using a decision tree? Okay, we discussed that how the decision tree functions, but does it provide any advantage as compared to your linear regression or logistic regression? So for example, in linear regression, we had some kind of a data set like this. Okay, uh, let us say these are the dots, and we had some kind of a dots here maybe. So what would happen? Our linear regression would try to balance out both these dots. I think it'll try to balance out this region as well as this dot, and you see that the linear line will be slightly deviated because of this outliers. But in the case of decision trees, what happens is, let us say that we have some kind of a age. Okay, now this is my age column. Let us say my age here is 22. Maybe here the age is 110. Let us say some person is very lucky to live to this age. 110 is the maximum age that the dataset has. Now, based on this, what happened to my mean? My mean will be slightly drifted towards the higher, correct? Because of this outlier. Actually, the median is somewhere here. Maybe this is my median. This is my mean. Now, in the linear regression, because it is trying to balance out even this outlier, that is why there is a drift. But what happens in decision trees, it'll try to divide this data set into bins. For example, let us say that I want to find out how much data do I have in quarter one, how much data do I have in quarter two, how much data do I have in quarter three and quarter four. Now, outlier is present in quarter four. Irrespective of wherever the outlier sits, my decision tree is not gonna get impacted because of that, because I'm segregating my data set. There is no linear relationship here at all. So when you look at an outlier that is present in this particular data set, it is still not going to impact the other three, the other three child nodes. So that is why there is an advantage that even if you don't treat the outliers in decision trees, they are still robust. They do not fluctuate because of the outlier. But of course, if the number of outliers are completely more, then of course, then you're giving a very complete wrong data set to the decision tree. Okay, so this is one advantage that we can see. There is problem also. Now we spoke about advantage of decision tree, but what problem generally happens is, suppose you allow the decision tree to grow completely. You consider all the columns. Let us say I have like 10 columns, and I allow the tree to grow bigger and bigger. Okay, for each split I'm getting a lot of child nodes and I'm allowing it completely. The tree is growing. What generally happens in these cases is that your decision tree will perform really well on your trained data set. We discussed about high bias and high variance, right? So this will lead to high variance, kind of an overfitting. On your trained data set, you might get an accuracy of around 95% or 98% or even 100%. But when it tries to apply that patterns on the test data, it might not reach to this 95%. Maybe you'll see it at 88 or 85. So what would happen is, you do not want the tree to completely learn all the patterns that is present in the dataset. What I mean is, decision trees continue to grow until it classifies all the data to class 0 or class 1. Correct? So in order to do this, it might, because of a lot of wrong data set, or a lot of maybe too many outliers or too many wrong records, it will try to classify it, continues to do this activity until it reaches to the point where it has all the classes as one class with zero impurity. But in by doing this on the test data set, it doesn't follow the same rules. It might fail. So in order to control, what we can do is we can prune the tree, stop the tree from growing. That is called as pruning. Don't allow the tree to grow continuously. So let us say if I have to split a column to 5, okay, maybe like 5 child nodes. There is a possibility that decision tree can make 5 child nodes. So what I'll do is I'll say make a minimum of 2 and a max of 4 child nodes or 3 child nodes. Don't go beyond this. So what it will do is it'll try to maintain the number of child nodes to just 2 or 3. We can discuss this part in hyperparameter tuning, wherein we say what is the split that we can allow and what is the depth that we can allow. How much deep can I go? When I say deep, it is the number of columns that I'll consider for making a decision tree. So this is column 1, this is column 2, this is column 3. Maybe this is column 4, like that. So the depth of the tree depends upon how many number of splits I make. So I can, that is also a hyperparameter for our decision tree. So we can discuss about hyperparameter when we talk about like the Python session of decision trees. Okay, but for now, just take it in mind that decision trees are prone to overfitting. This can be a very obvious question in machine learning jobs when they ask you why is decision tree good or why is it bad. Then you can say the decision tree is good because it can train easily on the data set and it can converge or reach to the point of conclusion very fast. But on the contrary, it can also get overfit. It performs very well on the trained data but performs very bad on the test data set. The way we control this overfitting is by pruning the tree. Keep a control on how much depth the tree can grow or how much wide the tree can go. Okay, these are the two things. This will help us reduce overfitting in decision trees. I have given the matter here. If you want, you can just read out at a later point. This will be uploaded. Okay, so we will see a small demo on uh, Python for implementing the decision trees in a while, and then I'll also tell you one complete application of how we can make one app ready by making use of APIs and doing the trains, saving the model, and also using that model for making a prediction. So I'll try to show that video also. Okay, for now I think we are good. If you have any doubts, you can just leave a comment and I can address that as soon as possible. Thank you so much.